Okay, Josh, I can record, so you can go ahead and get started.
All right. Thanks everyone for joining. This is our 5th webinar, Introduction to the Fledermaus module. My name is Josh. Along with us here today, you just heard the voice of Erin Heffron, who will be the presenter today. And again, also with us is Anya Duxfield. She's in the background here with us, and she'll be helping answer questions that any of you may have. First off, I just want to tell everyone about the GoToWebinar control panel. There's some options in the control panel where you can ask questions, and these are just basic, text, email questions or test questions that you can send to us. And also there is a hands raised option. If you raise your hand, we can then unmute you, and you can ask your question at a certain point during the presentation with Erin. Just so you all know, everyone is muted right now, so no one will be able to hear you until I unmute you. Next here I'll show you just our events page, just the upcoming webinars that we have. You can find this on our webpage under the news section, under the events, and we have 3 upcoming here coming with the ArcGIS integration, which will be September 8th will be our next webinar. So right now, I think that's all I have to say, and I will hand the controls over to Erin.
Okay. All right, show my screen. All right, the first thing before I get started, I just want to briefly show you what your interface screen looks like, which Josh talked about a little bit. This is the GoToWebinar attendee view. Just bear with me a second. I'm showing on the wrong screen. See if I can get that to work. Okay, this is what your view looks like of the GoToWebinar screen. So here you'll see what I'm presenting, and then you should have a little control panel over on the right here, which lets you interact with us, with the panelists, and with me, the presenter. So if you have a question you want to ask, you can type it here in the text box, or you can raise your hand here. And that will help you to interact with us here as panelists and organizers. All right, so let me kill that one. And so this webinar is about the Fledermaus module. Let me get my PowerPoint up and going here. And I have 2 screens, so it's messing with me. So just bear with me one moment. All right. Again, this webinar will be based on the Fledermaus module and focus on the Fledermaus module. And if you read the invitation that went out, the things we're going to cover is basic bringing data into Fledermaus, doing some draping of images, just really the core Fledermaus module tools. And there's a lot in Fledermaus that we won't cover, which we may cover in another webinar later. But just keep that in mind. That's what the goals are for this webinar. All right, so an overview of what we're going to talk about today. We're going to do hopefully about no more than 15 minutes of PowerPoint, and then I hope to move on to actually demonstrating the software and working within the software. The first thing I'm going to talk about is just the Fledermaus suite as a whole, a quick overview of that. I'm going to review very quickly the version 7 workflow, how things work now that we went from version 6 to version 7. And then I'm going to spend the rest of the time really focusing on the Fledermaus module and things that we're going to do. We're going to import gridded and ungridded data. We're going to add and drape images, and then how to create some core products that you might need as part of your day-to-day job. And that will include working with the profile tool, exporting maps and images, and how to save and distribute scenes. Just real basic, I do have some people who are brand new that were registered for this webinar, so just kind of start from the beginning. What is Fledermaus? Fledermaus is 4D visualization and analysis software for marine information. And what it's used for, I see that this is cutting you off a little bit, so let me get rid of that. Or maybe I can. Okay, there we go. And what it's used for, 4D visualization, primary and ocean mapping. We do real-time visualization, and that has to do with our vessel manager module, which lets you monitor a vessel in real time. We do project management and data manipulation. That uses the D-Magic module and Fledermaus. We do geospatial processing for multibeam sonar and LiDAR data. That uses what's called the 3D editor and the PFM data structure, and that's kind of an advanced topic. We do backscatter processing and mosaic creation using the FM geocoder module. We do route planning, that's for pipeline and oil and gas with the route planner module. And we have a free viewer so that people can download our SD and scene files or be given them by people doing work for them and view them without owning the software. So it's a pretty broad software suite used by a lot of different people for a lot of different things. One thing that everyone tends to have in common is most of our clients are working in ocean mapping or inland waterways. We do have some people who are not working with bathymetric data, and that's fine, but we have tended to really focus on ocean mapping and the bathymetric realm. All right, so just an overview of the entire suite of the Fledermaus software. It is a suite of software. There's many different modules, and if you're in Windows and you go to your Start menu, this is what you'll see in your Start menu. There's a folder called Fledermaus version 7, and in there you have access to all of your different modules. Just basically, I'm not going to talk about any of them today other than Fledermaus. I'm going to pop up iView 4D as well, and maybe OmniViewer, but we're really going to focus on the Fledermaus module. We have modules for doing data QA and QC, and that's called Crosscheck. D-Magic is a module for creating projects and organizing your data. We're not going to talk about that today, but there is a webinar about that later, I believe, at the end of September. Fledermaus is the core module, and that is where all of the visualization occurs. It's our core visualization engine. So if your goal is to really just get data in and visualize it, you're going to be doing it in Fledermaus. Okay, I have a note that I'm a little quiet, so I'm just going to take a moment to try and pump up my audio if I can. Don't know if I can do it. Can anyone hear me now? Is that better?
Sounds much better there, Erin.
Okay, so it's just probably getting my default.
Yeah, let's just try that for a bit and see if any other questions or any other comments from anyone else. So. Okay, sorry about that.
Okay, so back to the Fledermaus suite. Where was I? Okay, Fledermaus, core visualization engine, and what we're going to focus on today. You can do almost all of the core visualization tasks directly in the Fledermaus module, and I will show you how to do that today. FM command is our command line options. It's kind of a user interface to command line tools. It explains what options are available on the command line and helps you set up your commands as well. FM geocoder is our backscatter processing and mosaicing. FM Midwater, which you see here, is not available yet. It will be available in version 7.2, and that will be an optional module that can be added on. It won't be included in any of the software bundles. iView 4D is our free viewer. OmniViewer is an attribute viewer that lets you look at data files, particularly ungridded data files that you wouldn't necessarily be able to open in something like Notepad or WordPad. Route Planner lets you edit routes, very oil and gas focused. And then Vessel Manager is the module that lets you monitor the location of vessels in real time, and that works within the Fledermaus scene. Now, depending on what bundle of the software you have, you may not have all of these modules. So just a quick overview of the bundles, and I'm really not going to talk about this very long. I'm just going to kind of point you to it. We do have several bundles, and they're really focused on different users and different workflows. We tried to narrow down the options to suit what people need it to do. So at the I would say bottom end, but it's not bottom end at all, is FMVis 4D, and that's the most basic. And that includes Fledermaus and dMagic and lets you do all the core visualization. After each bundle is an example of somebody who might use it. And then at the top end, we have FM Pro. And FM Pro pretty much includes everything. And that was true up until the upcoming 7.2 release, when the new module FM Midwater will not be in the Pro bundle. And I'm sorry if I go back. I have the location on our website here if you want to find more information about that. Okay, so focusing on Fledermaus. Fledermaus, we use this term interchangeably. Fledermaus is the name of the entire suite of software. It is also the name of the main module in the Fledermaus suite, the core visualization engine. So I, and all of us at IVS, tend to throw that term back and forth and may not be very specific about what we're talking about. But for the majority of today, when I say Fledermaus, I'm talking about the module itself. So there it is in your start menu, and that's what the icon looks like on your desktop. We also abbreviate it FM quite often. So what kind of data can you bring into and use in Fledermaus? This is our point data imports. This I just got from our website. And you can, on the next page, it will show you where that's available on our website. This is the ungridded data formats we support. Now, don't worry too much about this read, unread, and write. That has to do with the PFM data structure, which is an advanced topic. As far as importing data to grid, you can bring in all of these files directly into Fledermaus and grid them up. Probably the most common would be ASCII XYZ, GSF perhaps. But quite a few common and multi-beam proprietary formats are listed here. As far as gridded data that you can bring into Fledermaus to visualize, this is a list of our gridded data imports, also from our website. And down here I have the link, the location of where you can find that information. As far as gridded data, this is data that has already gone through a gridding algorithm and been decimated. Ungridded data is not truly raw, but it's the original point data, probably cleaned, but it's not decimated. It's randomly organized data points. Once you get to a gridded data set, that data has been decimated and as a smaller data set has already been gridded. And these are examples of gridded data formats that we bring in. Again, we have gridded ASCII, which is a very common format. The ArcView formats are an option. NetCDF is something you might find. That's a lot of data online might be in NetCDF format. Geotiff grids and floating point grids also pretty common. So that's our list of gridded data imports. These are the two main formats of data, two main file types that come into Fledermaus, gridded and ungridded data. That's what we really focus on. We focus on visualizing the bathymetric data, and we make bathymetric 3D and 4D SD files based on gridded and ungridded data. We also bring in some ancillary data formats. So this is extra data that you bring in to enhance your visualization or aid in your interpretation and analysis. We can bring in images, and over here is just the import menu from Fledermaus, and that's where you find the option to bring in all of these different different data types. We can bring in images in TIFF, JPEG, bitmap. Vertical images, that's used most often to display seismic information. You can bring that in as a vertical image. We can bring in lines and points as ASCII XYZ. Import PFM. The PFM is a Fledermaus format, but it is an advanced file that lets you access soundings, and we're not going to talk about that at all today. You can bring in DXF and DWG from AutoCAD, Esri shapefiles. 3DS models, these are models of things like often boats or AUVs that you want to bring in to enhance your scene. 3DS format comes out of 3D Studio Max. And we bring in S57 ENCs. These are the electronic nautical charts that have the extension 000. So all of that can be brought in to help improve the look of your scene, make it cooler, or more importantly, help you really fuse your data together and see all the information together, make a really robust 3D scene. So that's what we bring in. Then you move on to what we actually create, and these are the Fledermaus file types that we are going to generate. The first one is the SD file, also called scientific data object. That's what it stands for. We tend to use the terms data object, object, just object for this. It is one set of data. So here is an example of a single SD file that is profiled over in Fledermaus. It's one set of data. You have different types of SDs. The most common one is the DTM SD. So that what we will create from gridded and ungridded data. We also call this DTM SD by different names. So just to get it out there, people call these terrain models, bathymetric models. They might call them DTMs or surfaces. So lots of different names for the same thing. The second type of file that we create is a scene file. That's when you have many, many different SDs and you save them together in one package. Here's an example of a saved scene with several different SD files visible. I have an image SD. Here I have a bathymetric SD in the center. And there's a draped orthophoto SD in the gray area there. Most scene files are self-contained. There's only a few exceptions. That would be ones that have PFMs associated with them. And with the release of FM Midwater, some of those objects will not be inherently packaged with the scene. And then the third file type we create is a PFM file. This is a advanced topic, like I've been saying. It's a file type specifically for editing multi-beam or LiDAR data. Here's what the PFM looks like. So here's a small bit of a PFM surface. It looks a lot like an SD surface, but you have the option to select on it and see the soundings. We're not going to talk about this at all today. You cannot create a PFM directly from Fledermaus. You have to use imagery, and the ability to create the PFM file type is only available in certain bundles. The bundles that are more focused on people doing bathymetric and LiDAR processing. All right, so moving on, that was the file types we import and the file types we create. Now I'm going to just move on to how the workflow goes once you start bringing that data in. We have two workflows post version 6, so starting with version 7. The simple workflow really focuses on using Fledermaus for import and analysis. You can use Fledermaus to directly import ungridded and gridded data, imagery, drape images, manipulate color maps. You can do that all directly in Fledermaus. However, if you have a lot of data for a specific area and you really want to get it organized, you might choose to use the project-based workflow. The project-based workflow uses a combination of dmagic and Fledermaus to organize your data and then visualize it. We already did a webinar about this version 7 workflow, really explaining why you might use one or the other. It was called the version 7 workflow webinar. It was back in July. And if you are interested in this, you can email me and I can send you the download link so that you can go through all of that. We're also going to have an introduction to dmagic module at the end of September where I really go through working with dmagic and how you set up projects and things like that. But this workflow, today we're really going to focus on this simple workflow. So what do I mean by a simple workflow? Again, you can import data directly. You can drape imagery and scalars directly. You can export images into maps. So you could do really all the core visualization things. You would use a simple workflow if you just have a bunch of data for one area and you want to get it in and visualize it. If you're not really worried about seeing every piece of data that was collected in the area. Also, if you're out on a vessel and you just want to quickly check some files, see what kind of data you have coming in, you might just pop it into Fledermaus and grid up one or two files quickly. So that's another way that you might use the simple workflow. And here's kind of what a basic, simple workflow looks like, a very, very, very basic diagram. You'll have ungridded data examples of ungridded data are XYZ, GSF, HS2. You'll import that into Fledermaus. You might have some data that's already gridded, which you'll import into Fledermaus. When it comes into Fledermaus, it automatically creates an SD file. This is what the icon for an SD file looks like if you have these floating around on your desktop. And then once you have all those SD files in Fledermaus, you might save them together as a scene. And this is the scene icon. It's just slightly lighter than the SD file icon. All right, so very, very simple workflow. Most people do much more outside of this, but this is the real core, and it is quite simple. However, to work directly in Fledermaus, to use this simple workflow, you must know a little bit about your data, or you must be willing to guess, to be a bit flexible. You have to know, is your data gridded or ungridded? This is usually something you know based on the file extension, or if somebody told you, or sometimes by the size of the file. It can be confusing with XYZ data because that can be gridded or ungridded. So at the worst, you can try it, and if it doesn't work, try the other option. You want to know your data format. This isn't as important. With ungridded data, we often know what the data format is based on the library and the file extension. Sometimes with gridded files, when you import them, you're going to have to choose the type of file it is. Again, if you don't know for sure, make a guess, and if it doesn't work, you can try again. You're going to need to know the projection and coordinate system information. You would find that in the metadata for the files, perhaps in a survey report, but it is important, and you will need to know this information. To work directly in Fledermaus, you're going to need to know the cell size for your ungridded data, or at least be willing to make a guess at what you think it is. And finally, you're going to have to know the gridding algorithm that you want to use. If you don't know the cell size, that is something that you can estimate in dmagic. So if you don't know that, you may choose to use the project-based workflow so that you can estimate cell size. But in Fledermaus, it's not going to show you anything about the file during the import. You're just going to have to put in a cell size and see what happens. This is my only version 6 slide, so version 6 users. In case you're wondering what happened to DTM, Geo, and Scalar, they are gone. We go directly to an SD file now. And that's pretty much all I'm going to say about it. We're trying to really move away from version 6. We have a depreciation schedule up on the website here if you want to check out what's going on with that. If you are still struggling with a transition from version 6 to version 7, we can do a kind of personalized webinar. I can do it with you if you're a client under maintenance. So you can email me and request to set that up, and I can go through it with you and make sure you understand. All right, so enough talking for now. Let's get into Fledermaus and bring in some data. So the first thing you're going to do if you're using the Fledermaus module, you're going to open it up. So here's my Fledermaus icon on my desktop, or I can go to my Start menu, All Programs, Fledermaus version 7, and there's the Fledermaus module. Double click to launch that. All right, so here's the Fledermaus interface. Just a quick brief introduction. I'm not going to go into too much detail because I want to make sure we get through a lot of things here. But basically, the center area is called the main visualization area, and that's where you see the bluish gray box. In the left corner, this is called the data object area, and that's where files will be listed. And in here is the object attribute area. So once we have an object listed, you'll see its attributes on the right over here. Menus up here. Geographic information will be displayed in the lower left corner. All right, so this is the main Fledermaus interface. All right, first thing I'm going to do to get us started, I'm going to import some gridded data that's already been gridded in a different program. The files I'm going to be working with, just to get you oriented, because I am going to be popping back and forth in this folder, I'm going to be working from this Portsmouth data folder where I have everything divided up into the kind of data it is. So I have an ungridded data folder where I'll be getting my ungridded data. I have a gridded data folder here where I can get my grids. If you're not familiar with gridded or ungridded data, just basically, I'm going to be bringing in a gridded XYZ file. If you're unfamiliar with your files, if you don't know what's in them, it's not a bad idea to open them up in a text editor or in our OmniViewer and see what you have in your file. So just for example, this SSO1 bathy, or the SSO8 bathy, that's what we're going to be looking at. If I open this up, just a simple file, 3 columns, X, Y, and Z. I can see just by looking at this file that this data is in a UTM coordinate system because these are not latitude and longitude coordinates. So just by opening that file up and taking a look at it, I can get a little bit of information about the file. I can also see that the depth is the 3rd coordinate and that it's negative. In Fledermaus, if you're bringing in bathymetric data, we assume that the Z is negative, that it actually has a negative sign in front of it if you were to open the file up and look at it. If that's not the case, there's a place where you can invert it, but we do assume negative depths. If you do not have negative depths, you'll go through the import process and you'll get a mountain instead of a basin, and it's not a big deal. You'll just have to do it again. So that's what a gridded data file looks like. Another clue that this might be gridded, these are really round numbers here, so often that kind of tells you that it's probably gridded. Also, the fact that it opened up in WordPad is a good sign. If it was ungridded XYZ, it'd probably be a really, really large file, and WordPad would have really struggled to open it. So if you have a really huge XYZ file, you're probably dealing with ungridded data. Anyway, this is gridded data, and this is what I'm going to bring in first. So let me minimize that, and back to my Fledermaus screen. All right, to bring in gridded data, simple as going to import gridded data. All right, so I just have to browse to find my Portsmouth folder, gridded data. And I'm going to bring in the SSO8 bathy. All right, so I've selected that file. The first screen I see, what is the file type? You can get the down arrow here and you'll see all of the options for gridded data. This is ASCII gridded data, just a straight XYZ file. So I select that. Click Next. What kind of data is it? This is an XYZ file. We saw that when we opened it up in the WordPad. Sometimes you'll have an ASCII file that just has a Z variable, but in this case, XYZ. Some XYZ files have data headers, and you can choose to skip those header lines here, but this one does not have any. It's just a straight XYZ. So I can click Next. This page asks you about the mapping of the columns. So in an XYZ file, the data can be arranged in the order XYZ, where X is field 1, Y is field 2, and Z is field 3. That's not necessarily the case. So another good reason to open it up in WordPad or OmniViewer and take a look at the file and make sure that it's in this order. If your X and Y are reversed, which could happen, you would just click the down arrow here and choose the proper field. If you don't know, it will never kill you to take a guess, and if it doesn't work, kill that file and make a new one. This is a straight up XYZ file, so I can go with those 3 columns. Click Next. Next one, the input coordinate system of the data. So very important. What is your file in right now currently that you're bringing in? And we saw, again, in Notepad, when we opened it up, that this file is not in WGS84, which is the default here. It's in some kind of projected coordinate system. Now, if you don't know anything else about the file, you might have to guess. I know that this data is in Portsmouth, New Hampshire. I know it's in UTM Zone 19 North. So that is what I'm going to choose for my input coordinate system. Common coordinate systems are listed in the down arrow here. So I see the geographic coordinate systems at the top, followed by all the common UTM zones. If you have a different coordinate system, all you have to do is hit the select button here, and this will take you to our full coordinate system projection library. And you should be able to find just about any projection that you might need in one of these folders. If you have your own that you've custom created, you can import it, or you can edit or create here. If you hit edit, create, it will let you actually edit whatever's in there, so you can bring in your own center lines and things like that. If you've been using ArcView and Esri ArcGIS, and you've created a coordinate system there, you can import that here. And we do support the if I get that down, the Esri PRJ file. So you can import that and use that coordinate system as well. All right, mine is a common coordinate system, so I can just X out of there and go to zone 19 north. As far as the vertical datums, currently we leave this as undefined. We have this here in kind of to set the stage for when we do support vertical datums, but for the time being, just leave it as undefined. Click Next. We'll just take a moment, and it was going to scan through your data. It's getting the bounding information, so it just takes a minute. So it's scanned through my file. It's giving me the bounds here. It's telling me the rows and columns of my final grid. This is kind of a useful screen. First of all, if your grid data dimensions are over 10,000 by 10,000, you're going to have a problem. So take a look there and make sure that they're not. If they are, you're going to have to break the grid up into smaller pieces. Another good thing in this import gridded data screen is the bounding information. If you look in these boxes and you're seeing numbers like -70.4 here, that data is probably geographic and not in UTM. So if you set it to UTM, you made a mistake and you want to go back and set the proper input projection. Also the Z information, I see that it's listed as negative here. If you have positive numbers here and you're expecting bathymetric data, you're going to want to go and you're going to want to invert it when you get to the final screen. This data all looks fine, so I can click Next. If I had to invert the data, I would do it here, but I do not have to do that. Finally, I'm going to select this output coordinate system. Now, right now, the default output coordinate system is WGS84. My data is in zone 19, so if I left it as this, I would be reprojecting the data, which I do not want to do. So I'm going to set this to zone 19, and that's going to just say that I want the data to stay in the projection that it's in, and I want my resulting SD file to be in UTM zone 19. Click Next. Finally, what kind of SD type do you want to create? 99% of the time, you're creating a sonar DTM file. We also call this a surface DTM in some of the wizards. It means the exact same thing. This is just your standard digital terrain model file where your Z value is bathymetric or topographic data, some kind of elevation information. If you want to create a scalar is a file where the Z equals something other than depth or height. So if you are gridding magnetic information, then you would choose to make a scalar. What do I want to save the SD file as? I'm just going to carefully put this in a folder that I've made called the working folder, so I know where to find it. So I'm going to browse. Be careful in Fledermaus of where it defaults to save. It may not necessarily be where you want it to be. I want to keep everything together in a working folder. So I'm going to select that. And I'm going to keep the default name of SS08 Bathy. For gridded data, it will maintain the default name. And save that. Finally, color map. You can choose a color map here. Now you have to be really familiar with the Fledermaus system color maps to use the color map option here because you browse and all you get is the list to our library. You don't actually see them. If you're not familiar with our color maps, don't worry about it. Just take the default because you can change it later within Fledermaus. So I'm going to leave the default step 16 color map. and click Finish. All right, so just a few moments later, and my gridded ASCII XYZ file is now a Fledermaus SD file. It's listed down here in the data objects. When I select on it, I see that there's data attributes over here on the right. All of these tabs are associated with this one SD file. If you've never used Fledermaus, a brief introduction to moving around. Don't want to spend too much time on it. All rotations occur around the center of the screen, and it really helps to have a mouse to use Fledermaus. To move around, I have a 3-button mouse. It has 2 buttons and a scroll. If I left-click and drag in the X or Y plane, I'll start rotating in that direction. To change direction, you stop, left-click again, and I can move in the other plane. So, a little slow on what you guys are seeing, but I'm moving up and down in the other direction. All rotations around center, so to move the center, put your mouse where you want to go and middle click or push down on the scroll button, and that will change your center. To zoom in, you scroll in with the scroll button. And to zoom out, you scroll out. And your last mouse button is your right click. If I right click and drag, I get a profile anywhere on the surface. All right, so that's really brief introduction to moving around in Fledermaus. These things are called the widgets. They show you direction here. If you can see the top of that gray widget, there's an N for north. Other important things, your vertical exaggeration is here above the objects, and your vertical exaggeration is defaulted to 6. If you want to change that, you can physically type in a number such as 1 there and hit enter, and it will change your vertical exaggeration. That also makes it a lot less interesting, so I'm going to put it back up to 6. Okay. Once you have an SD file, you have all kinds of options that are over here, and these are the data attribute options. Briefly, what you see over here, the DTM tab tells you information like the grid size. It lets you use transparency on the surface, and it lets you change from shaded surface to wireframe and plates. The wireframe, if I scroll in, is a connection of the node centers. So that's what a wireframe looks like, if you can see that. The second tab is the color map tab. This is where you'll see the histogram of your data. So here's my data spread across the top. Here's my data range and also the color map that's used. It's a little squash, so I'm going to stretch this box out a little bit so you can see it a little bit better. But here's the color map range, the name of the color map. And if I just expand my screen a little bit, also over here, you'll see in the color map tab, there's the option to change your color map and also a tools button that lets you edit your color map. Changing color map's easy. You just go and you pick a different one. And this time when you choose a different color map, you'll actually see it displayed. Editing color maps is a whole other story and is something I'd like to go into in an advanced webinar. We don't really have time for it now, but you can edit your color map here. All right, other tabs that you have, the shading tab shows you the sun direction and angle on your surface, and you can change that here. If you make any changes, you must hit the shade button to see the changes occur. The balance tab gives you the extents of your data. So here's my X, Y, and Z min and max extents for this one SD file. Georeferencing tells me the coordinate system the data is in. The time tab is for doing things with time and keyframes, also an advanced topic which I'm not going to get into. And info, very basic metadata about the SD file. All right, so that's the first way to bring data in, importing gridded data. When you import gridded or ungridded data, you're always going to make a DTM SD, and you can see here in this tab that it says DTM. The second thing I'm going to now import is ungridded data. Josh, just before I go on, anybody with questions or everyone doing okay?
We're doing good here.
Okay, very good. Okay, next I'm going to import some ungridded data. So, ungridded data, data that has not been decimated.
Sorry, Erin.
That's okay.
Sorry, Erin. As soon as you answered that, we had 3 questions come up.
Okay.
Or hands come up. So I can try to unmute Mark Borelli. I'll just see if I can unmute you here. I don't know. You might have to. I just sent you the audio pin, so you might have to enter this in before, as you're on a telephone.
Yeah, the audio pin you have to type into the telephone to make yourself unmutable.
There we go. I think he's good.
Great. Can you hear me?
Yeah.
Yes, we can.
Great. When we went to the georeferencing tab, because we're kind of doing it along with you guys with our own data, the coordinate system changed back to the default, even though we had entered a different coordinate system.
Are you sure for the output coordinate system that you changed it?
We didn't have an output coordinate system option.
You probably did and you missed it. It's in a separate tab from the input coordinate system.
Okay. Well, all right.
Okay. If you go through it again and you're still having problems, just ping me offline and I'll help you figure it out.
Thanks.
Yep.
Okay. We have another one here from Mahesh. All right. I think.
Yeah. Can I go ahead?
Yeah. Go ahead.
Yeah. My question is, when we import the battery data into Fledermaus and when we see it in color format, so is it possible to know the sun illumination angle?
The sun illumination angle. If I'm going to shading, the azimuth is the angle.
And for this one, the start angle, the 0 degree starts from where? Because it normally differs
north?
from software to software.
I believe 0 is right
okay.
at north there. So as you go around the circle up to 360.
Oh, okay, no problem. Thanks for that.
No problem.
Okay, thanks. Yeah.
Okay, thanks, Mahesh. And I don't know.
Yeah,
I think.
thanks, man.
I think Mark might have another question here. Just I might not have unchecked it, so just one sec. Hey, Mark, you're live again.
Oh, no, sorry, I forgot to put my hand down. We're done.
Oh, okay. Okay, good. All right, Erin.
Good to go? All right. Next option is importing ungridded data. To import ungridded data, it's pretty much the same thing. It's going to step us through a wizard. But just briefly, before I go through doing it, you're going to have to choose a gridding algorithm when you import ungridded data. So let me just bring up this PowerPoint slide briefly. Hopefully you can see this. I don't want to go into presentation mode. Let me zoom in a bit. With the gridding algorithms, and I'll show you where this is in the wizard, there's 5 options for gridding algorithms. If you don't know what I'm talking about, don't stress out too much. You'll see where it is when we go through the wizard. But the 5 options, this is how you take that ungridded data, those raw data points, and choose the way to decimate them. The default option is a weighted moving average. And when you use a weighted moving average, you specify a cell size. So let's say this red block is our cell. And you say, okay, within that cell, I want to take every point that falls in that cell, and I want to do an average of it. And then in addition to that average value, I want to look at the surrounding neighbor cells and take into account the values in those cells as well, and do a little bit of smoothing between this average value and these neighboring values. The weighted part is the number of neighbors that are taken into account. And when you choose a weighted moving average, you set a weight. 3 will look at the next 3 cells surrounding the cell of interest, and 5 goes out 2 levels of interest. So that's a weighted moving average. If you just want an average without a weight, you can choose a weighted moving average with a weight of 1, and then it will only look at that center cell. The shallow biased algorithm will take the minimum value in each cell, the shoal, and that's really navigationally focused for people who are worried about making sure they get the shoal-less surface for, again, navigation. Median filter will take the median value in each cell and make that the surface value. Deep will take the deepest. I can only think of one reason to use that, and that would be if you're looking for deep outliers to make sure that your data was cleaned properly. And a root mean square will do the root mean square. That only works for topography, so it will not work for negative data. All right, so those are the 5 gridding algorithms. We don't have tons of them, and they're pretty simple. We do have documentation on these if anyone needs more information, but that's pretty much it to choose from, so it's not all that complicated. So let me minimize that, and let's bring in some ungridded data. So import ungridded data. All right, slightly different introduction page. You have to add files. You can choose to add files or add a directory. Usually when you're importing ungridded data, you're importing many, many lines because you're out collecting multibeam data, and each pass of the multibeam is a separate line. Sometimes that multibeam data is given to you as XYZ, and again, someone's giving you a folder with a bunch of lines in it. That's not always the case. Sometimes they put it all together in one giant file, but those files can get to be very large, which is often why you get separate files for ungridded data. So you can choose to add ungridded by the add file or add directory option. If you are a Keras user, it's important to note that you always have to go through this add HIPS data button. You have to have your Keras dongle plugged in. You have to have Keras installed on the machine. So all of those have to be met for this to work. For all other data types that we support, you can use these options. I'm going to add files. I'm just going to go into my ungridded data folder. I'm going to go in my 2001 Bathy GSF. These are GSF ungridded files. If you are not familiar with GSF files, don't get freaked out or anything. GSF files stand for generic sensor format. It's just a way of storing often multibeam data, and pretty much all it is XYZ data with a lot of other attributes. So if you open a GSF file in OmniViewer, which I'll do in a moment, you'll see the XYZ and a bunch of other information. So just to show that to you and also introduce you to our OmniViewer. So I'm stepping aside from this wizard for a moment. Don't get confused. I'm going to go to Start, All Programs, Fledermaus 7, and OmniViewer. And this is our attribute viewer. This is not a necessary step. I just want to show you how you can look at a file like a GSF file. File and load the file. And if I go into Portsmouth, ungridded data, and load one of these GSF files and take a look at it, all it is a bunch of columns. 3 of the columns are latitude, longitude, and somewhere along there there's a depth. And then a bunch of other columns that are telling you information or leaving empty space for where information can be stored for multibeam data. So there's a lot of excess columns in a GSF file. But the important columns to us are the X, Y, and Z. Another good reason to look at this file is to see if it's projected or not. And I can see here in this GSF file that I'm looking at latitude and longitude coordinates. So that tells me right off the bat this data is not projected. It's in a geographic coordinate system, and I'm going to assume WGS84. So that was very useful to me just to see that before I go on with importing my data. So again, not a necessary step. I just wanted to show you that. Minimize OmniViewer. All right, so now I'm just going to select all my GSF files. There are a bunch of files, so it is going to take a minute to get these files in, but hopefully you'll bear with me. All right, so I've selected a bunch of GSF files that I want to grid together. There's about 66 files in here. You can have one, you can have many. That can be whatever's listed in the source data files will be gridded together. Click Next. All right, the value to grid. So what value do I want to make an SD file out of? It's going to default to the depth column. If you have a generic ASCII file or something where there's no headers and it doesn't know where the Z value resides, you can go into this configure button and choose which column you want to make a surface out of. So you can see that the latitude is the Y value, the longitude is the X, and if I scroll down, I'll find the depth is listed as the value to grid. If you wanted to grid, for some reason you wanted to grid the pitch or roll, you can make those the value to grid. Other things to do here, if your data is not negative, if the depths are not do not have a negative sign in front of them, you can choose to invert them here, and that will make them negative. I don't have to do that, but with XYZ data you might have to. I don't have to change anything in here, so I could just say OK. Input coordinate system of my data. My data is in WGS84, so I can leave the input coordinate system alone. Output coordinate system. I've already brought a file into my Fledermaus scene that's in UTM zone 19. So for things to display together in Fledermaus, you do have to have them in the same projection. So in order to bring this data in and have it display correctly in my Fledermaus scene, I'm going to have to reproject it. So I'm going to make my output coordinate system zone 19 north. And it's going to reproject from geographic latitude and longitude to UTM coordinates. Click Next. What's my gridding type? Here's where you choose one of those gridding algorithms. I am fine with weighted moving average, so I often choose that option. And I'm good with a weight diameter of 3. You can go from 1 and up, and it should be an odd number. If you put in an even number, it will just round to the next highest odd number. You have to choose a cell size. The cell size is based on the depth of the water that the data was collected in. You should know this, hopefully, if somebody's told you this or you're on the survey and you know the cell size to expect for your data. If you don't know, places to look are the metadata, survey report, and if you cannot find any information, you can use dmagic to estimate the density of data per cell. So if that's something you need to do, you should come to the dmagic webinar and see how to do that. I know that my cell size for my data is 4 units. Units is units of the data. Now, this can be a bit confusing. If I was in WGS84 and I was staying in WGS84, these units would be in decimal degrees. So you would have to specify your cell size in decimal degrees. Because I'm going from WGS84 to UTM zone 19, I'm specifying my cell size in meters. A clue to this, when I got to the screen, the default that was typed in was 25, and that's the default for meters. If I had a default of something like 0.001, that's a clue that it's looking for it in decimal degrees. But it's going to be in units of the data and what the data is going to be in when it's finished the import process. Kind of confusing, but hopefully you guys got that. So I have to scan the file for bounds, and this will take a minute. And I can say right now that I'm going to go over the hour. So if you have to leave, please feel free to leave at any time. I will not be offended. If you're enjoying yourself and learning something, please stick around. And I will try to wrap it up as quickly as possible, but there's a few things I want to get through. So sorry for my not being very concise.
Another thing to mention there too, Erin, is that the webinar is being recorded.
Yes, it will be recorded, and anyone who is on this webinar can download it afterwards. So if you have to leave, you will get the information to download it. So don't feel bad about leaving. We will get the information to you. So right now it's just scanning the files, getting the bounding information. It does take a minute to go through all the files. So
while we're waiting, we do have a question from Uday.
Okay.
It's a hand-raised question, so I'm just going to unmute him.
Okay.
All right. I believe I pronounced your name right.
Hi, Uday.
Are you?
You there?
It doesn't look like we're hearing
Uday,
him.
we can't hear you, so if you want to type your question and we can get it via text. Okay, I've scanned through all my files and you'll see the bounds are listed. Again,
Can the cell size be found in the header of the data?
sometimes, depending on the file, it might be in there. But
Sorry to interrupt you there.
No, that's all right. If it is in the header, we won't read it there. Like, you have to open up that file and read that information. For ungridded data, as far as I know, we don't read any header that tells cell size. But in an ASCII file, you might have that. Somebody might have typed that into the header information,
Okay.
and you can open it up and look at it.
Yeah, that was a question from Laura. So Laura, if that answers your question, just let me know. And it did. So sorry, Erin, go ahead.
That's all right. Very good. All right. So file has been scanned. Again, take a look at these bounds. Make sure they make sense. If you chose to reproject, they should be in UTM-looking coordinates here, and your z's should be negative. So good thing to take a look at. Here's the resulting rows and columns you'll get for your DTM. And again, you don't want to be above 10,000 by 10,000, or it's not going to work. Click Next. This is where you can choose the color map if you are familiar. If not, you can again change it later, so you can leave the default. Click Next. And finally, what are we making? And this is the same as the gridded data, except for some reason we call it a surface DTM here, but it's the same thing. You're going to make a surface DTM anytime you're using topography or bathymetry. And just make sure you're saving it in the right place and give it a name. So I'm going to click on the browse. It's saving it where I want to, but I'm going to call this SS01 Bathy. Give it a name and save and finish. And we have to wait again while it grids the file. So another good time for questions if anybody has them. If you are sticking, oh, go ahead. Sorry,
no, I was just going to say I'm just looking through and I don't see anything. So.
Okay. If you're sticking around, the things I want to get through yet, imagery. I want to show you how to drape images, and then the export options. So that's what we're going to cover as quickly as I can without losing everybody.
All right, Erin?
Yep.
We have one question just came in from Steve. Does OmniViewer view file types other than GSF?
OmniViewer will open and view any point file type that we support. So it will do GSF, HS2. As far as I know, every ungridded format we support. It will open gridded XYZ data, but I don't think it will open any other grid format that we support, only the ungridded.
Okay, we have another question if you have time there, Erin.
Yeah, go ahead.
From Steve Hearn. If you have a 10 by 10 limit on this SD scene, can you stitch images together later to create a larger image set?
The 10,000 by 10,000 limit is not on the scene. It's on the individual SD that's brought in. So if you have to break up a file, you can create individual SDs from chunks of data. If you merge them together, it's going to put you over that limit. That's something called a DTM merge, taking individual SDs and merging them together later. But there's no reason that you absolutely have to merge those files. If, for example, I had to break this file up and it was in 4 separate chunks, they would all display together very beautifully, and so I wouldn't have to merge them. So if you have to break things up, you should still be able to make a really nice visualization. The SD limit is 10,000 by 10,000. A scene limit is more based on computer memory and such, and is about 2 gigs for 32-bit systems, and that's you can talk to Josh more about that, but your scene limit will be a little bit less than 2 gigabytes. Okay, so we have a new est file over here. This is you see over here on the left that I have 2 objects, and this is a good time to introduce a button. If I click on my new SS01 Bathy in the list and go over here and hit this button here, which is a camera with pointing to an object. That's the zoom to object button, and that will zoom you into the extent of that object. And the hotkey for that is the Z key. So if I did it to the SS08 bathy, for example, if I select on that in the data object list and hit Z, it'll move me to that object. So that's a nice way to move around and find your data. Here's my new object. It's another piece of bathymetry. Very similar to the gridded data. Once it comes into Fledermaus, they're all SD files, and they all look pretty much the same. If I select on the SS01, I can take a look at its properties, and I do see that the cell size is 4 meters. So the SS08 is 1 meter data. This is higher resolution over here. You can get all that information from your attribute tabs. And briefly, if I scroll out, you'll also see that this box grew. I'm going to hide the widgets by clicking on this button so we can see. This gray box is the bounds of the scene. So this box will grow as you add data in. The bounds of the scene are important because they're going to come into call again later when we do map sheets. But you'll see this is the full extent, and this gray box goes to the full extent of every data object that you have in your scene if it's turned on or turned off. Okay, so that's gridded and ungridded. Next, I want to get into bringing some imagery into your scene. For images, we support TIFFs, JPEGs, and bitmaps. You can import images horizontally, directly, if you want to display something like a chart. You can import images vertically if you have information like seismic data. We're not going to go through that one in this session. You can also drape images. So I'm going to import an image, and I'm also going to drape some images and show you how to do that. The first thing I'm going to do is just import an image that I want to display horizontally in my scene. I'm going to import a chart for the area. This was just a nautical chart that I got from NOAA. I had to convert the BSB that you download from the NOAA site into a geotiff, and I do that using the NOAA chart reprojector, which is available on their site. We don't read BSBs, but we do read geotiffs. So I'm going to import image. Go to Portsmouth, and in my imagery folder I have some charts. And I have a big chart and a small one, but for the interest of size I'm going to get this smaller chart here and bring that in. So this chart was a geotiff, so it came in very nicely. It went right into its proper location. If I go to the georeferencing, we read the georeferencing information from the TIFF. No questions asked. If you have a properly referenced geotiff, it will come in that nicely. Occasionally you bring in a geotiff and it recognizes that it's projected, but it doesn't know the coordinate system. And at that point you'll get a warning that says something that it doesn't quite know the coordinate system. It will come in as assumed UTM, and you can choose to set the coordinate system when you bring it in. But if everything's set properly, it should come in nicely. So if I zoom in, just a geotiff of a NOAA chart, you'll see that it comes in around 0. So my bathymetric data is underneath. In Fledermaus, there's no layering. Things come in at their proper Z's, and for images, they come in at 0. So they're always, or usually above the bathymetry. If I turn the chart off, I can see the bathy. Now, if you want to see through that chart to the bathy, you can do a few things. You can select on the chart and just manipulate its transparency. And that will let me start to see through the chart to the bathymetry beneath. And hopefully you can see that on your screen. You can physically change the height of the chart, so I could select on the chart, and here is the chart's height. It's at 0. I could say, let's knock that chart down to -40. Oh, maybe that was too far. Let me try 20. I think it's below my bounds. There we go. Now my chart is mostly beneath the bathymetry data, and I could keep tweaking it. So right here where I see it cutting through the bathymetry, that means there's some bathy that goes below -20. So I can lower that chart to maybe -30. I'm not sure why that's going on, but 25. All right, so that's another option for chart data. Another thing you can do with flat images so that you can see through to the bathymetric data is you can choose to mask them. The way the mask works, if you select on the chart image and go to the tab for image, you'll see here under the image and tools, there's a compute mask button. This will knock a hole in the image anywhere where there's overlap with other pixels. So in this case, I have two objects turned on underneath. I have this Consberg data underneath here, and also this, the SS08 bathy and the SS01 bathy. If I leave those both turned on, when I compute this mask, I will get a hole where they're located. Just to show you how it works, I'm going to turn off the SS08 bathy before I run the mask. So I've turned off the file that was over here, but I've left on the center file. Turn on the chart and go to Tools and Compute Mask. And once that runs, you'll see it's knocked a hole right here over the central data set. Okay, so you can see that, and if you get on Edge, you can see where it's actually knocked the pixels out of the image. If I move back out and turn back on my SS08 bathy, you'll see the chart is still overlapping that data set. So if I wanted to knock those out, I would just turn that file on and recompute the mask. And if you don't want to see the mask, I can select on the chart and turn off the mask out areas, and then I'll have my full chart again. Okay, so that's the first thing you can do with imagery. Second thing you can do with imagery that people like to do is drape images. I'm going to turn off the chart for a moment, and now I'm going to work with some backscatter data that was collected over here with the SS08 bathy. To drape an image, you can import the image first, but you don't have to. You can just drape it from disk, and that's what I'm going to do. So I'm going to step you through doing that. I want to drape some backscatter data that I have on my disk on top of this bit of bathymetry. So you select the bathy data that you want to drape on. I have the SS08 bathy SD selected, so it's blue over here in the datasets list. And you can see these little yellow balls here. That's telling me that that data object's selected. Select on it and go over to the data attributes, and under the DTM tab, DTM Tools, there's a little Tools button. Under there, Drape Image on Surface. I select that. Now, you can choose an image from disk. That's what I'm going to do. Also, if you have an image loaded in the scene, you can choose that image. So if I wanted to drape the chart, I can choose a loaded geo image and select the chart here. But I want to choose a bit of backscatter that I have on disk. So I'm just going to browse and go to my backscatter folder. And I have just a tiny little bit of backscatter here called area of interest, and this was saved as a geotiff. When I open that up, it loads the TIFF. I can see that it has bounding information here, so it is a geotiff. So it's going to drape that image on my surface. The next option is the drape resolution. When you drape an image on top of bathymetry, it has to do some resampling. I don't want to get into too much detail because it will take up too much time, but the default of the draping tool is to take the best resolution of either the image or the data. Often your image has higher resolution than your data. Specifically, backscatter data can have 10 centimeter or quarter meter resolution, so it might be really, really high resolution image, and this is going to take the default. In this case, my image and my bathy are both 1 meter, so I don't have to think too hard about it. But if you have a very small number here, be careful, because it's going to resample the surface to that resolution. So you might end up with a really big data object. I'm going to leave the default here. The next bit is about applying illumination to the draped image. Applying illumination drapes the image on top of the bathymetry and then also runs the sun illumination algorithm on the object. So not only are you getting a drape, you're getting shadows. It's hard to explain, but it's easier to see. I'm not going to use it for this backscatter data, but I'm going to run it with the chart later to show you what that looks like. So you can choose to apply illumination. And then finally, what surface do you want to drape the image on? Current surface, we'll just drop it right on this bathy SD, this SS08. If you make a copy of the surface, it's going to make an exact copy. You'll have two objects in your scene then. One of them will have the drape on top. And the third is to new surface that surface to only the area of overlap. Especially with backscatter, this may be the best option for you, but after I do this drape, I'll show you what that looks like, and then I'll talk about that just a little bit more. I'm going to choose to copy the surface and put the drape on top. it's going to default to the name SS08 Bathy and draped. So it's saying it's your Bathy data, but you've draped something on top of it. And say OK. And I'll just take a minute to drape that on top. All right, once it runs, I have a new SD object here in the left, SS08 draped. And if I turn that off, it goes away. Now, you can't really tell, but if I turn off this SS08 Bathy, it is an exact copy of that original Bathy data, just with the drape on top. If I turn that off and that on, same file, but without the drape. So that's option number 1, and you can see it just put the backscatter on top of the area of overlap. The other options are to cut and drape. So let me just bring in one of those that I already created to show you what it looks like. All right, if I turn off my original and the Bathy, this is where I chose to use that same area of interest, but I chose the third option, which was to crop. And if you look at it, you can see that this is draped. There is elevation underneath that backscatter, but it's cropped the DTM to only the area of overlap. So why might you choose to do one or the other? If you have a really high resolution backscatter data set that you don't want to make lower resolution, you may choose to do this because then it will not resample such a large area to a high resolution. If, however, you want to drape bits of side scanner backscatter on the same DTM and you want to keep layering it up, you may choose to do the first option. And let me show you what that looks like. All right, if I zoom out, in this case, I draped the area of interest 1, and then I went through and from the same surface, I chose to drape another patch of backscatter. So you can keep using the drape image on surface tool and keep building up a draped surface. So the option you choose will be dependent on the file size that you're looking to get, and also if you want to add more data later. So you can make the choice that way. So those are the 3 different options. I want to show you quickly one example of a drape with shading, and I'm going to do that on the SS01 Bathy using the chart. So we're going to take this chart and drop it on top of this bit of bathymetry. I select the SS01 Bathy SD, Tools, Drape Image on Surface. This time I'm going to use the loaded geo image and select my chart that's already been loaded into my scene. And I'm going to apply illumination to the draped image. Finally, I'm going to make a copy of it because I don't want to drape it directly on. That is
Sorry,
what
Erin.
a drape. That's okay. Everything okay?
I was just going to say there was some really bad lag there, so yeah.
Oh, okay. Did I catch up?
I think you're good there now. You might just want to repeat just a little bit, possibly, what you just did there.
Okay. So what I did, I draped the chart using illumination. So I selected SS01 Bathy SD in the data attribute or the data objects. Again, I went to DTM, Tools, Drape Image on Surface. Wait for that to catch up. I chose to use a loaded geo image. It's the chart that's already been loaded into the scene. Select the chart, apply the illumination, and finally I chose to make a copy. All right, I'm not going to run it again, but that's the setup for getting a draped with illumination. And that's what it looks like when it's done. So it's not only draped the chart, but it's also run sun illumination over it. So I can see the chart information, but I also see the detail of the outcrops, and I don't lose any of the bathymetric information. So that's another option for draping. One final image thing, and then we'll get into export options. You can import ungeoreferenced images. An example of one that you might do is something I often do is go and snatch an image from Google Earth, and then I kind of rig in the georeferencing. So I'm just going to quickly show you an example of how that will work if you're interested. If you have an ungeoreferenced image, you import it the same way. So you'll import image, and in my imagery folder, I have a Portsmouth Google Earth image. Full disclosure, taken from Google Earth. Thank you, Google Earth. So I have this Portsmouth image. Now when it comes in, it's not displayed. If I zoom out, I see nothing. All I see in my datasets list is the name and the term undisplayable, and it's red. So this is telling me that something's not quite right with this image, and I need to fix it to make it displayable in Fledermaus. So if I click on the Google Earth image and go to its data attributes over here, the first thing I want to do is go to its bounds. And I'll see in the bounds tab there's no real bounding information. It's zeros and thousands. So that's only the extent of the image. That's not real coordinate bounding information. If I go to the georeferencing tab, I'll see that under the object coordinate, there's none selected. So this is an ungeoreferenced image. And to make it work, I'm going to manually georeference it. So how you do that, I personally just go into Google Earth and I hover my cursor over the corners and I type those numbers down and put them in a text file. So here in this little text file, let me shrink it so you can see it. And we'll just take a minute to catch up. Here I have a little text file where I just manually typed in the coordinates from Google Earth. I then went into something on the web that did a conversion for me. I just Googled it and did the conversion to UTM. And here are my bounding coordinates for this image. So I can select my image here in Fledermaus. Now I'm going to have to bounce back and forth. So let me see if I can line these up so you can see what's going on. All right, in Fledermaus, select my Google Earth. Go to the Bounds tab, and now I'm just going to copy and paste these numbers into here. So just Control-C and Control-V to copy and paste. And when I'm done, I hit Apply. Oh, what did I do? I did something wrong. Min X, min Y, max X, max Y. Interesting. I just tried that an hour ago and it worked just fine. Max X. Okay, well, I'm sorry, it worked an hour ago, but you should just be able to type those bounds in, and then the final thing you'd want to do is change the georeferencing and set it to the proper UTM zone. So I would say UTM zone 19. But very embarrassingly, it's not working for me now. I'm going to just try it one more time because I swear it worked not that long ago, so bear with me. Well, persistence paid off. I'm not sure why it didn't work the first time, but the two things you have to do, just so you know, you have to copy the new bounds into the box, and you also have to change the georeferencing. So I put the bounding information in, and then when I went to the georeferencing, it was listed as assumed UTM, and all I did was say that it was in zone 19, because that's what these coordinates were in. And after being a little persistent, it now is in the proper projection, and I have a nice Google Earth image of the Portsmouth area. So let me get this back up. And this is nice to really get people into where your scene takes place. And again, with this image, I can make it transparent to see through to the back, the underneath. And it just looks really nice in your scene. All right, so that's all I want to do with imagery. The last things I want to talk about are exports and products that you can get out of the main Fledermaus module. So things that you need for your everyday life. First and foremost, you can save out SD files as geotiffs. You might want to save them out as geotiffs to take into another program to use as a base map somewhere. It'll just make a nice high-res georeferenced image of the SD file. So let me do that first. I'm going to turn off the Google Earth image, and I'm going to focus in on my original SS08 bathy data. So I'm going to turn off everything else to cut down on distractions. All right, I want to make a geotiff of just this one surface. To do that, select the SS08 bathy SD, go to the DTM tab and Tools, and say Export Surface as Image. Select on that, and I'm just going to make sure I'm saving it somewhere so I could find it. And I'm going to call this SS08 bathy geotiff. You can see the file type is a TIFF file that's georeferenced. And click Save. All right, so once it does that, just to show you the results of what you get, in my folder, I now have a new file here, if you could see it, called SS08 bathy geotiff, and it is just a TIFF file that will open in an image viewer of that file. So it looks really nice and really high res, but it's just a flat geotiff, and you can take this into any other program that will read a geotiff. It's georeferenced. It is black around the edges, and that is also something that can be fixed in dmagic. So if you want to learn how to do that, come back for the dmagic webinar. All right, so that's option number one for a product that you might use in your everyday life. The other type of geotiff that we create is called a map sheet. And a map sheet is going to make a geotiff image similar to that one, but it's going to be of every object that's turned on in the scene, and it's going to be to the full extent of the bounds. So what does that mean? That means when I use the map sheet tool, which I'm going to do in a moment, it's going to make a top-down geotiff that is the same size as this gray box, if there's data there or not. It always does the full extent of the scene. You would use the map sheet if you had a lot of data and you really wanted a geotiff of the whole thing. So if I were going to do a geotiff, I might turn on every little thing that I have here. Okay, I'm going to turn off this because that's a bit noisy. So you would turn on whatever you want to be in your final geotiff map. Again, no matter what, if you could see it or not, it's going to be the same extent as this gray box, and it will have whatever turned on that you choose to turn on. To make a map sheet, you go to Tools and Map Sheet. If you weren't top down, it would flip you top down in the visualization, and it will show you with the blue box the extent of your final geotiff. So it's saying, look, it's going to be this big, just so you know. You have two options with a map sheet. You can do a geotiff or an annotated map in EPS. Geotiff will just do a straight geotiff. Nothing matters with map scale. Map scale does not matter with a geotiff. You don't have to worry about it. You can choose to make the background transparent with the geotiff, and that will get rid of that black or white color. And you can bump up the magnification if you want, and that's going to give you a higher resolution map, but it will also make your file quite a bit larger. If you choose to do the EPS, that only opens in some image viewing softwares and Adobe programs, but with an EPS you can choose to do a north arrow, have a map scale, and do some basic annotation. Geotiff, you can't do that, but I don't have Adobe, so I'm going to make a geotiff, and I'm going to make it small. I'm going to export, and I'll call this Portsmouth NH, and save. All right, and then again, back to my folder, not that one. In my folder, I have a new TIFF up here called Portsmouth, New Hampshire, and if I open that, opens in an image viewer, and again, like I said, you'll see that the actual image is much, much larger than where there was data. So if you want to use the map sheet option, your best thing to do is to only bring into the scene the data that you want to have turned on. If not, you're going to be taking up a lot of extra space and losing resolution for no good reason. But this, again, is a geotiff that can be taken into other software that rates geotiffs. All right, so those are your two geotiff options. If you want an image of an oblique view, something more for a report, say you really like the look of this, you can zoom into your area of interest and then go to File and Screen Capture. Wait for your audience view to catch up. So File in the menu and Screen Capture. That will take a screen capture of whatever you have in your visualization area. So this is just going to make a normal screen capture, not georeferenced, of whatever is visible. So I'll call this Main Harbor. It's going to save it as a TIFF. You can also choose a JPEG or an EPS. And again, you have the option to do magnification. And by using higher magnification, you'll make a higher resolution image. So if you're making an image for a poster, it's always a good idea to bump up this magnification because it will give you a better product. But it will make your image size much larger. So be careful. I often have to bump up this magnification for making products like the calendars that we put out or to send things to magazines. Click Save. And back to my folder. Here is the product of that export option. Just wait for that to catch up. Okay, so just a nice oblique view of what was in your visualization. Another thing that people have been doing a lot lately is exporting to Google Earth, and we can do that very easily from Fledermaus. It's a really nice thing to do to give to clients to show them where you're working or to put on your website to show people where you've been doing work. To do a Google Earth export, let me zoom back out here, you choose the SD file that you want to export. So let's turn off some stuff again to focus. And let's say I want to export to Google Earth this SS08 Bathy here. Select the object that you want to make the Google Earth export of. So you just select it in the list, go to Tools, and Export to Google Earth. So select the object, DTM tab, Tools, Export to Google Earth. Once you do that, it will bring up the Google Earth Export Wizard. Where do you want to put it? So the output directory is just where it's going to make the KMZ files. What do you want to call it? You give it a base name, and I'm fine with the default of SS08 Bathy. Do you want to tile the image? If you have a really large data set, you might choose to tile it, break it up into pieces. I'm going to keep the default for the image tile size. Link to the original data. This is just a place where you can put in pretty much whatever you want, and when you see it in Google Earth, it will have that listed under the data set. So I'm going to put something there just so I can show you an example. This data is from Shallow Survey 2008. So I went to the Shallow Survey website, and I'm just going to copy there the link to shallowsurvey2008.org. And I'm going to paste that into here. So it's going to put the information that this is shallow survey data into the Google Earth export. I'm going to compress it into a KMZ. You can choose to start up Google Earth automatically. Web-ready files I am not an expert on, but if you guys have questions about that, Josh might be able to answer it after we get through at the end. I'm going to say OK. Just take a minute to export that out and pop up Google Earth. All right, so if I get in there, a nice image of your Fledermaus SD. Now this is just an image, it's flat, but it looks really nice and it gives people a really good idea of where you're collecting data or where you're working. Also, if you look over in the temporary places under SS08 Bathy KML, here's my link to the original data. So that's the link that I put in to the Shallow Survey website. So Google Earth export, very, very easy out of Fledermaus. Two more things to talk about, and thank you all who are sticking around. I really appreciate it. Sorry I'm babbling on but I really want to help you guys understand how you can use Fledermaus. Last two things I want to show you is the profile and how to save a scene. So I showed you at the beginning, you can right-click and profile anywhere on the surface to get a nice profile. This is dynamic, and you can just go and do it anywhere, but you can also save this profile out. When you create a profile, this is called the profile window, and in the profile window you have the option to save the profile image or save the profile. Save profile image will just make a TIFF, and that will pretty much be a screen capture of what it looks like in the profile window. So I've just went to that file and double clicked to open it. So that's the TIFF image. If you choose to instead go to Tools and Save Profile, this is going to save out a text file with the X, Y, and Z along the profile and also the distance along profile. So I'll just do one of these quick. The sample interval is how often along the profile you want it to take a sample. And if I open that up in a text editor, that is what this export looks like. So first column, distance along profile, and then X, Y, and Z. Finally, the last thing you might want to do as a product is save this as a scene. So right now we have a bunch of SD files that are in our Fledermaus, but they're not saved as a scene. When you save a scene, it will save this all together in one package that you could pass along to somebody, or the next time you open it, it will have all of your objects. When you save the scene, it's going to save it in the last way you had it. So you should choose to turn on what you want to see when you open up the scene. So maybe I'll have the Google Earth image on and just my Bathy data and make the Google Earth image a little transparent. Then I go to File and Save Scene, and I can call this Portsmouth NH, and it will save it with a .scene extension, which is the other file format for Fledermaus. Once my scene is saved, I can close Fledermaus. A scene file you can open up in Fledermaus, but you can also open it in our free viewer, which is downloadable on the web. So just to show you how what that looks like, I'll open up iView instead of opening Fledermaus. So under Fledermaus version 7, I also have IV4D. This anyone can download from our website. They just go to ivs3d.com and look for the free viewer. Open up IV4D, and I can now open scene file. So I'm sorry, I'll slow down. File, open SD or scene, and I can choose my Portsmouth, New Hampshire scene. So this is what a scene file looks like in IV4D. It looks exactly how it looked when I turned it off in Fledermaus. You have the option to see all of the objects, and you can turn them off and on, and you can interact with the data. So iView is a good way to let people look at your data or interact with it. They don't have nearly all the tools that you have in Fledermaus, but they can visualize the data. Okay, so that was pretty much it. Just in summary, thank you all for sticking around, and I'm so sorry that took me so long, but I hope you learned a lot. In summary, things that can't be done in Fledermaus. You can do a lot in Fledermaus, but there are a few things that cannot be done in Fledermaus. And they include, let me let that catch up. You can't do image editing in Fledermaus, so you can't crop images or add transparency. That has to be done in dMagic. You can't plot ungridded data to estimate data density. If you don't know your cell size of your data, another reason you might use dMagic. You can't export grids or ungridded data as a different format. That, again, dMagic. If you're interested in the PFM format, you have to build those and work with those in dMagic. They are visualized in Fledermaus, but they have to be built and manipulated and unloaded in dMagic. The rugosity and slope algorithms, they only live in DMagic. And the ability to interpolate and resample grids are only in DMagic. So these are things that you might consider some basic tools that you would have to use the DMagic project-based workflow to be able to access. But that said, most core visualization tasks can be done directly in Fledermaus. You do have to know a little bit about your data, and if you don't, you might choose to use DMagic because it gives you a better overview of your data to start with. And you can do many common exports and create a lot of products very easily in Fledermaus. So that is all I have. Again, sorry, I apologize for going on so long, but if anyone has any questions, I'm willing to stick around and answer them. And for the rest of you, thank you very much for attending our webinar, and we will send you download information in a little bit, and please keep coming. Thanks.
Awesome. Thanks, Erin. We did have one question there a while back from Uday. He was just wanted to see if you can maybe explain the edit controls on the Fledermaus window.
I can. Yeah, I will do that.
Just if I think he's still here, so just let me check to see.
Well, I'll show them for anyone who's still around.
Yeah, he just had a question, and it'll be recorded too, so I don't see Uday here actually right now. Oh, no, he is so yeah, that'd be great.
I will open the scene and I'll show that. So anyone who is, wants to leave, go ahead, and for the rest of you, I will keep talking until we're out of questions. So the edit controls in Fledermaus. These were new with version 7, and what he's talking about within Fledermaus, over here on the right in the control panel, there's quite a few buttons that I didn't talk about. Obviously, I ran out of some time, but there are some edit options here, so I'm going to try to explain those briefly. These let you manipulate any SD object in your scene, and sometimes they're more appropriate than others. The 4 edit controls are translate, which will let you move something in X, Y, and Z. Rotate, which will let you rotate around a central pivot point. Scale will let you rescale the SD and move the pivot point. So I'm going to show you how they work. To do it, I'm going to show you on the SS08 Bathy. Now, you very much would probably not do many of these manipulations to a bathymetric data set. If you do, you're going to want to save it as something else, because when you use these tools, you are changing that data set and you are changing its georeferencing. The edit tools are really good if you're trying to manipulate a model of a ship and you want to get it into location, or if you want to move an image around and get it into place, but it does change georeferencing, so be very cautious. If I want to use the edit tools on this SD, if I try, you select the object of interest, so SS08 Bathy, and then you select the tool you want to use. Now it's put the translate axes here right in the middle. If I go to move this, it's going to yell at me. It's going to say, you cannot move it, it's locked. And this is our way of kind of protecting you from yourself. With DTM SDs, we lock them by default. If you want to move them, you select the SD and you choose right here where the little lock icon is to unlock it. Now you can do anything you want, and if you screwed up, it's not our fault, so be careful. All right, so my SD is unlocked. I've chose to translate, and what this little thing in the center of the screen is a translation axis. And to make it work, sorry, don't know what I did there. To make it work, I'm going to pull on one of the cones. So I just moved so that you could see a little bit better. There's 3 cones along either axis, and I can just drag on them, and I can move this object anywhere I want. Okay, so that's how translation works. Left clicking and dragging on the cone of interest. Rotation gives you a rotation axis, and again, you left click on the axis you want to spin in, and you can turn, and it lets me spin it all around. And scale will let you scale in either any direction or in all. So if I click and drag on this red plate, it will scale in one direction. If I click and drag on the white center bit, it scales in all directions. You can see once I've done all of these edits that there's a little star next to the SD. That tells me that that SD file is changed. And if I want to save those changes, I have to physically either right-click and save the object, or when I close the scene, it will give me the option to save it as well. If at this point you've decided that was all a really bad idea, you can use the undo button and eventually get back to where you were. So I've just undone all of my changes and got back to the original. The last one was pivot point. All of the movement occurred around the center. If you want to pivot on another point, you can move it. And then my rotations will occur around that point. All right, I hope that helped explain. And again, it's not necessarily something you would do to a DTeam file, but really useful for models and moving small images into place or tweaking seismic data to make it fit nicely into your scene.
Okay, Erin, thanks. Just one more question that was from John. He was interested if you could show an import of S57 NOAA chart into a scene. I don't know if we have time for that or not, or if you have that data available right there.
I think I do. Let me look and see if I have one. If I do, okay. I'll show you how to do it. Oh, while I'm on it, after you use the edit modes, make sure you go back here to explore mode. When you're usually moving around your scene, you're in explore mode, which is the white cursor. When you change to an edit mode, your cursor has changed functionality. So if I try to move like I normally would here by left clicking, I'm still in an edit mode, so it's moving my surface. When I change back to explore mode, then I'm in normal Fledermaus moving mode. All right, so let me see if I can import an S57. To do it, you import, import S57 ENC under the import menu. And I think I have one. All right, so an ENC file is a small nautical chart file. They tend to be really, really tiny because they can send them out over the internet. We do not display nautical ENCs in the way that you're probably used to seeing them. Most people display ENCs and they look very similar to a geotiff, but with a lot more information. When we display ENCs in Fledermaus, we vectorize them. So we turn each part of the ENC into a separate vector object. And if this works, you'll see what I mean in a second. Okay, so here it brought in a really large ENC of the Maine and New Hampshire coast. Here is the ENC object at the bottom of my dataset list, and this is the first object we brought in of this type. This is a parent object. So when I brought in this ENC, here's the name, and there's a little arrow next to it. That means that there's more objects that are available underneath this parent object. If I hit the down arrow, I'll see tons and tons of little SD objects. And these are all of the individual parts of the ENC. So things, you have to have the ENC library to know what these abbreviations mean, but they mean things like buoy, contour, locations of lighthouses. If I zoom in to the ENC, I'll see things like sounding information here, and that's part of the ENC. The red is a contour, and that's part of the ENC. You'll see, again, buoy locations, lighthouse locations, and all of these are separate objects, and that's how we deal with ENCs. Anybody else? And did that answer your question, I hope?
It's looking good there, Erin. Sorry. Yeah. Now John just got back. And it looks like it's good. All
right. The last thing I want to say, unless there's any other questions, there is a lot more in Fledermaus that we haven't covered, and I didn't intend to. Under tools, we have things like contouring and surface difference. You can edit color maps. You can do a lot in Fledermaus that I didn't have time to cover. And at a later point, I'd really like to do a Intro to Fledermaus round 2, where we go through more of those tools. So if you're interested in something like that, email me, let me know.
Sorry to interrupt there again, Erin, but John did have a little follow-up. He said, cool, so we do not have to worry about projection?
Okay, that's a really good question. With vector data, and this is kind of complicated, vector data, so shapefiles, DXF, ENCs, and also ASCII points and lines that you import here. So when you import lines, points, DXF, shapefile, or ENCs, vector type data, it is reprojected on the fly. They are the only things that do that. Surfaces, images, you have to think about projection information. With vectors, it will read the information and it will reproject it on the fly to the scene coordinate system. So very good question.
All right. That answered John's question. He says, brilliant, thanks. So
No problem.
I think we don't have anything else. Oh, actually, just one. No, I think we can answer that offline here. So.
Okay. If anyone has any questions or has any requests, you can email the GoToMeeting at IVS3D email or eheffron at IVS3D. Oh, one slide I didn't show you. If you have webinar-related questions, requests, feel free to email me. If you have bugs, please email our fine folks at support, support at ivs3d.com. There's also a link to support on our website. They will be able to help you much more reliably than me. So other than that, feel free to email me.
Okay, great. And thanks to everyone, and thanks, Erin. If there is some questions, I see there's some questions coming in, but I think we're going to cut this short right now, and we'll answer your questions offline. We have everyone's email address, and we have a log of all the questions that have been asked and answered. If there's a question that hasn't been answered, we'll just get back to you. So again, I'd like to thank everyone for joining. Thanks to Erin, and we hope you enjoyed the webinar, and hope to see you on our next one.